Hey guys, so today we are going to start our new chapter on key features and piecewise functions. Okay. Um, the key features, I'm hoping this all sounds familiar. I just might challenge you with different graphs that we need to go through. Okay. So we're gonna kind of split these things up. All together we'll have 2 lesson videos of our key features, but that's up to you on if you want to do it all at once or so on and so forth. Again, because a lot of this should be reviewed. Okay. All right, one thing I want to tell you is this. I actually have these written ahead of time. So, because I'm a slow writer and I don't want you guys to wait. So if you have to pause the video, write down the definition, so on and so forth. Okay. So the first thing we're looking at is domain. Domain, of course, is all the x values of the function. So you want to think of it that when we do domain, we're going to do it in interval notation. Now, we talked about domain and algebraic and everything before, and we talked about problem functions versus no problem functions, so on and so forth. But considering we're looking at graphs and we're looking at piecewise, we also have to think about, hey, are there arrows at the end of our function and do they go on forever, or does it start and stop somewhere, so on and so forth. So we're going to interact with different graphs with that. Okay, so domain, of course, is all our x values. That's left to right. So remember, left. Pencils are great. Left to right. And then our next one is range. And that's all of our y values. You want to think that's down to up. Again, looking at that arrows at the very end or start and stop type of thing. Next one, x-intercept. Well, we know x-intercepts. We've been solving them for a while now. It's where the graph crosses the x-axis, and you have to remember that an x-intercept is a coordinate pair. So you must write it as your number, comma, 0. Okay, I will not just take 4. You have to write it as 4, comma, 0. X-intercepts are a coordinate pair. Okay, same thing goes for a y-coordinate. Y-intercept where it crosses the y-axis, so a 0 comma number. Now keep in mind, guys, that there can be multiple x-intercepts, right? And there doesn't have to be any x-intercepts, but there could be multiple, where y, you either have none, no y-intercepts, or you have one. Because if you have more than one y-intercept, it is no longer a function, and we're only dealing with functions, okay? Keep that in mind. Excuse me. All right, symmetry. This might be something new this year. I don't know. So we're just going to describe it as we're looking at the graph. So later on this year or next year especially, you'll learn how to prove symmetry algebraically. But right now, we're just going to look at it graphically. So symmetry is we're talking about, does it have an even, an odd, or neither symmetry? Okay. So if it is even, specifically, it has to reflect over the y-axis. And I gave you an example right here. Okay, so the left side and the right side match. Where an odd, it looks like you would rotate it around the origin. Okay, so one of the best ways to figure out if it has an odd symmetry is you would want to turn your paper upside down and you'd be looking at the same graph. Okay. And then neither, which is going to be most of our graphs, right? Or so it's not even or odd. All right. And then the last thing we're doing today is end behavior, which we have done multiple times before. So we have our left side, what's happening at the left side, and what is happening at the right side. Now, specifically, limit is as we approach. So as we approach negative infinity, as we approach infinity. Okay. You are going to have to write down that limit notation. Okay. We're mathematicians right now and everything, so I'm not going to write it for you. You're going to have to write limit as x approaches negative infinity of f of x, our graph, What does that equal? Where is it going? Limit as x approaches infinity of f of x. Where is it going? Okay. All right, let's get into some examples here. So we have this example right here. As you can see for end behavior, I wrote it ahead of time because I wanted to go fast. Okay. So domain, what I want you to keep in mind is there are supposed to be arrows right there. Okay. So domain, as we go to the left, that arrow keeps going out here. And that arrow tells me I keep going all the way left to negative infinity. And then on my right arrow keeps going out like this, and it keeps going right also to infinity. The other thing I want you to think of domain is this. If I were to squish this whole graph on this x-axis right here, right? If I squished it, my arrow would be going in both directions. So negative infinity to infinity, okay? That's another way to think of domain. Okay, range, how far down, how far up? Okay, if I go back to that squishing example I just showed you, and we were to squish it onto the y-axis, we would have a solid dot right there, right? Solid dot right there. And we would have our arrows would come together like that, okay? So if I were to look at that range, well, how far down does it go? It goes to 2, and it hits 2. And then it keeps going up, and that arrow keeps telling me it goes up to infinity. Okay, so do you have to imagine it squishing on the y-axis? You don't, but it's another way to do it. Okay, x-intercept, where does this cross the x-intercept? Remember to count your stuff. This is halfway in between 2 and 4. Watch for those units, right? This is halfway between 2 and 4. That means our x-intercept is at 3, 0. Oh, that's the y. What was I thinking? Because the x-intercept crosses the x-axis. Do we have any? No. It is 7:30 in the morning. I need to wake up, apparently. So as we said before, it's 3, 0. Okay, symmetry. Remember, even says it reflects across the y-axis, so it's the same on the left as the same on the right, or odd says that it rotates, like if I turn my page, we got the same graph. No. And neither is nor even or odd. So here's the thing. If we flipped our paper across the y-axis, do we get the same? Yes, we do. So this symmetry is even. Okay. And our end behavior, well, our left arrow is going up, and up means infinity. Our right arrow is also going up, so that is also infinity. Okay, let's see if I don't have to make a common mistake. Okay, luckily on this graph, it shows us our arrows for us, right? So domain, even though the left side is going down here, it's still going out to the left, which means negative infinity. The right here, it keeps going out to infinity. Okay, again, if I were to squish it on to the x-axis, my arrow would be going left, my arrow would be going right. For my range, if I squish it onto the y-axis, right, my arrow continues down. So an arrow going down is negative infinity. And as I go up, I go to the value of 2. And as I can see, it hits 2. There's no hole there. So that means it is bracket. Okay, x-intercepts. Okay, this time where it crosses the x-axis. Okay, I see that there are 2 of them right here and right here. Okay, so at -4, 0, and at 0, 0. Very good. Okay, coordinate pairs. Y-intercept where it hits the y-axis, so that is at 0, 0. Okay, symmetry. Remember, we're just talking about even, odd, or neither. As I can see, my left side is not the same as my right side, so not even. If I turn my paper upside down here, do we get the same graph? No, we did not. So since it's not even or odd, it is neither. Now, many of you might say, but Ms. Heckman, there is symmetry, but it's just not even or odd. There's symmetry as it reflects across y equals -2, which is true, but we're just talking about even, odd, or neither, not symmetry on the graph itself. Okay. Or the function. Okay. So, oh, and behavior, which way is our arrows pointing? They're both pointing down. So they're both going to -infinity. All right, last one. This is a piecewise. For those of you who've never seen a graph like this is why it's called a piecewise, because what we're doing is we're taking different functions and putting them together. We're only taking pieces of the function. So if you look here, we have this function that curves, right? And by the way, there's an arrow. So put an arrow there, and it starts here and it stops at 0. Then we're going to take another function and take a piece of it and go from 0 to, it looks like 2 right there. You can't see the lines. And then we have this other function here that starts at 2 and continues off with an arrow at the end. Okay, so again, this is the 3 functions pieced together. So when you think of domain, this is where that squishing really helps. So if I brought this graph up to the x-axis, this is what it would look like. It would have an arrow here and it would go to 0. And then if I bring this down, it would have a closed dot right there, right? And then if I brought this one up, it would have open and an arrow this way. Okay. Now, this open and close cover each other, so technically it's closed. So I don't have to worry about any gaps. So my arrows go from -infinity and we keep going all the way to infinity. Okay. I'm going to erase this so I don't confuse myself on my graph. Okay. That's how to do it there. Your graphs are going to have some gaps, so make sure that you look at those, like, hey, if it looked like something like that, if we squished it on the x-intercept or x-axis and it did something like this, I know that there'd be 2 intervals, right? Because there's a space in between, and you'll have some practice with that, okay? Okay, now let's look at the range. Remember, how far down and how far up. If I squish everything onto the y-axis, right? So this is squishing here, the arrow continues down, which means we start at -infinity. As you can see, this graph makes us go up to 0. This graph here makes us go up to 4. But if I squish this line onto the y-axis, this arrow continues going up. Okay, this hole right here is actually covered by this filled in point here. So it is still -infinity to infinity. Okay. Again, watching out for those gaps when it comes in. Okay. X-intercept. Well, don't forget we do have an x-intercept at 0, 0. And then if you look at it, it's at 4, 0. Okay. If you can't see the lines, sorry. And then the y-intercept, of course, is at 0, 0. Well, symmetry, this is obviously neither. And our end behavior, which way is our arrow pointing on the left side? Our arrow is pointing down, so that would be -infinity. And our right arrow is going up, so up is to infinity. Awesome, very good. What I want to show you though is something that we're going to do in the future. One is just a piecewise, I guess not. Hopefully it's on your homework. I know it's on your homework. Oh, right here. like this one. We'll do this one later. But if we talk about domain right now, domain is okay because if we squish everything on to the x-axis, they would all match up. But if you look at this and you say range, well, first of all, I would have this filled in and the arrow goes down, right? Because I'm moving this graph to the y-axis, okay? If I move this graph to the y-axis, it would be open here and open here. Okay, you guys do that. And then if I move this here, this would close this. It would close this and our arrow would be going up. But as you can see right here, there is an opening. So this range would be negative infinity to 1 and it's filled in. So it's a bracket. And then we start back up at 2 to infinity. So I just wanted to give you an example there of a gap in between piecewise, okay? Other than that, let's do some practice, see how much we remember all the domain, range, intercepts, symmetry, and end behavior.